Hello 啊，咁就有一排冇見大家啦。咁近排我自己就比較忙啦，一路都冇時間去經營呢個 channel。咁啱最近我個仔佢同學媽咪啦，咁就攞咗呢條數學題，咁就嚟請教我嘅。咁介紹翻呢條數學題啦，佢就係上一年小學數學奧林匹克嘅題目嚟嘅。呢條題對於小學生嚟講，其實我自己覺得都有啲 challenging 嘅，即係喺佢哋所學嘅 technique 唔足夠嘅時候啦，去解呢條題都有啲難度嘅。所以啦，咁我就趁呢個機會喺呢度解一解呢條題，咁就順便 update 一下呢個 channel，activate 一下佢。係啦，咁就因為啦，我個仔同埋佢啲同學仔其實佢哋都係用英文去學數學嘅，咁所以跟住落嚟啦，我哋解呢條題嗰陣啦，咁我哋都會轉翻個 channel 用英文去講解嘅。Okay, so let us go back to this question. And it says that, well, there is a track. Okay, we don't know how long is the track, but what we know is that in the very beginning, okay, let this one, we assume A, okay, to be red color, and B to be the blue color. Okay, they are running in this field, in this track. Well, in the very first time, okay, they are running at the same direction. And it says that, well, A will catch up with B at some point. Okay, maybe some point, let's see, okay, here, okay, they catch up for the first time. And this means, okay, what's going on here? A is running, okay, for over, okay, one round. And for B, okay, it just won, okay, that many. And that they complete the first catch up. And for the second time, okay, A is going to turn around and run anti-clockwise. And that means for the next time, okay, A will here and run in the other direction. But B, still, it keeps at the same direction, right? And so the second part of this question, it becomes the encountering problem. So, what we need to solve this question for sure, okay, we know that for the first part, it is the catch-up problem, right? And for the second part, it will be the encountering problem. And actually, we know, okay, we can break this whole question into two parts. But the problem is that, well, in this question, we don't know much about like the size of the track and the speed of A or the speed of B. Okay, we basically got nothing. So here, what we need to do is to make assumptions. Okay, for example, okay, here maybe I let the speed of B, okay, equals x, and the speed of A equals alpha x. And from the question, we know that the speed of A is faster than the speed of B, and which means here alpha will be greater than 1, right? We don't know, maybe it is 2, 2.5, or 3, or whatever. Okay, we got to solve it because this ratio is what we are going to figure out, and this is what the question is actually asking is here. What is the ratio, right? So this ratio is actually alpha, but well, we are still not enough, okay, because when we are going to solve the catch-up or encounter problem, we got to know the total distance, right? But here we have no information of the size of the track, so we also need to make the assumption of the size. So maybe we let, okay, the size of the track to be n. Okay, so now we can solve the catch-up problem for the first part, and for the second part to solve the encountering problem. Okay, so we see that from this question, okay, all we know is that, well, after the catch-up and the encountering, B finishes, okay, 3/4 laps. Okay, that means 4/3 of the track, okay, he have completed. And that means, okay, if for the first part, okay, B runs at the speed of x, and he takes like t1 of time. Okay, x times t1 is the total distance for the first meet with A. This is the distance that B runs. And for the second part, which will be the encountering problem, and the distance that B runs here will be x times t2. And from the question, we know that, okay, the summation of x times t1 and x times t2 equals 3/4 times n, right? It is 4/3 of the track, which means we have x times t1 plus t2 equals 3/4 times n. And what we are going to do is to plug in all the x and everything, okay, to replace t1 and t2. And hopefully, in the end of this question, we can solve this number of alpha so that we could answer this question. Okay, so now let's try to find out what t1 is. So t1 is the catch-up problem, right? So which is equals to the total distance for a track, which will be n, the size of it, over the catch-up will be over the difference of the speed, which will be the speed of A, alpha x, minus x, right? This is t1. We simplify this a little bit. N over alpha minus 1 times x. And similarly, t2 is the encountering problem. We got the total distance, which is this track again, and over, okay, the sum of the speed, which will be alpha x plus x. And we simplify this a little bit, it becomes alpha plus 1 x. And that's it, right? So now we plug in, okay, these two back to this equation, and let's see what we got. And we have x times, right, n over alpha minus 1 x plus n over alpha plus 1 x equals 3/4 times n. Okay, we use the distributive law, and we got, okay, x times the first part, okay, the x will be cancelled out, which becomes n over alpha minus 1. And similarly, x times the second part, the x will be cancelled out, so it becomes like this, n over alpha plus 1. And this one equals 3/4 times n. And we divided n on both of the sides of the equation. Well, of course, the size of n is non-zero, so this one becomes 1, and we cancel out. So what we got here is 1 over alpha minus 1 plus 1 over alpha plus 1 equals 3/4. Well, we almost finished. Okay, we do the calculation a little bit. Alpha minus 1, alpha plus 1, and what we got is 2 alpha here equals 3 over 4. Okay, let's do some more steps. 2 alpha over alpha squared minus 1 equals 3 over 4. And here what we got is 3 alpha squared minus 3 equals 8 alpha, right? We cross, we multiply on both of the sides, and this is what we got. And then we move all the alpha and the number to one side and trying to solve the quadratic equation here, which will be 3 alpha squared minus 8 alpha minus 3 equals 0. So this one, it becomes alpha minus 3 and then 3 alpha plus 1 equals 0. And which means alpha equals 3 or alpha equals negative 1 over 3. And clearly this is not possible, okay, because the speed of A is some possible number, positive number. So therefore what we have is alpha equals 3. And so finally we solve this question, right? The ratio, okay, of A, and this means, okay, the speed of A is 3 times of B. That means the ratio A to B is 3. And we are done. Okay, to summarize the technique that we have used in solving this question, well, the first one is the catch-up and encountering problem, right? We have to break this question into 2 parts, and then since we do not know the numbers, right, the speed and the size of the track, we have to make our own variables, and then we have to deal with all this variable and try to calculate the distance, the speed, and all the things with all the variables. So in this step, it may be a little bit uncomfortable for primary students because in most of the time, I think they are working on the numbers but not the variables. But it is okay as long as you practice more. Okay, things will get much more smoother because the operation, all of it, are basically the same as the operation in with numbers. And for the last one, which is the most not natural one, which is the quadratic equations, because in the end, what you see is this one right here, this one. So you have to think a way to solve it. So for the primary students, I think most of you didn't see how the technique all the way to solve this. So I guess this is the most difficult one, but it is still okay because once you have this quadratic equation, you can actually plug into different numbers to test it, right? You can try alpha equals 1, oh, not correct, equals 2, equals 3, and so on and so forth. Because this is a math competition or math contest, so the alpha must be some, well, for me, okay, my gut feeling will be some integer. Okay, it will not be very large, so I will test 1, 2, 3, 4, and so on. Okay, there must be some numbers, and of course in the end, okay, when you try out alpha equals 3, and whoa, suddenly, okay, the left hand side of this quadratic equation equals 0 and the right hand side, well, and you are done. So you know that the ratio will be 3. And so this is the last technique that we use. I guess this is not belongs to the primary students for the quadratic equations, but using all the things that you know at the moment, well, you can actually try out all the possible answers, right? So I guess this is the end of the video. And if you have any questions, just feel free to comment in this video, and I will try my best to answer your questions. And thank you for watching, and see you for the next time. Bye bye.